trying to figure out how many have at least one dog or at least one cat, but not both. So at least one cat, that's not going to be X. And at least one dog, that's going to be Z. I've gone the route of a Venn diagram because whenever there's an intersection, that's just the way my brain works. So I'm trying to find X plus Z. And I know from what's given that X plus Y plus Z plus W is 50. That's the number of households. All right, so now let's look at our clues. The number of households that have at least one cat and at least one dog is 4. Okay, so let me see. The number of households that have at least one cat and at least one dog is 4. Well, that's that intersection, so that means Y equals 4. But if I plug in 4 here, let me get my pencil back. If I plug in 4 there, that's just X plus 4 plus Z plus W equal 50. And that's X plus Z plus W equal 46. And I'm trying to find X plus Z, but I've got W in the way, so that doesn't work. All right, clue 2. The number of households that have no cats and no dogs is 14. That's a W equal 14. That's this guy out here on the outside. They do not have either. So that's going to go back up here. And that would be X plus Y plus Z plus 14 equal 50. And that would be X plus Y plus Z equal 36. And we're trying to find X plus Z, and I got Y in the way. So I can't do it. This does not work. So what do we do? What do we do now? We put those two together. And what do I have there? I've got, let's go back to this equation up here. I know that X plus 4 from that, X plus 4 plus Z plus 14 equal 50. And if I add 4 and 14 and then subtract it from 50, that's going to leave me X plus Z equals some number. And that's what I'm trying to find is X plus Z. So my answer is C.